Hi guys, Mrs. Snowden here, and we're going to talk about Trig Notes 1-5. So, a few things before we start. You need to have your identities memorized. This makes it a whole lot easier if you have your identities memorized from 1-4. So, as a reminder, those are the ones that I put in the box last time. Okay, so your reciprocal identities, you need to know those guys. Your ratio identities, those are tangent and cotangent in terms of sine and cosine. Need to have those memorized. And your Pythagorean identities. Mainly this guy right here. If you can memorize that guy, you can find those guys. And you can rearrange into both of that one and sine squared equals 1 minus cosine squared. Okay? You got to have those memorized. There's no other way around it. And pre-calc's going to expect that you know those as well. So, keeping those in mind, that's the first thing. Have your identities memorized. The second thing, when you're working with your identities, use cosine and sine as much as you can, okay? It'll make your life easier. And the last thing is that you have to use some sort of variable. Okay, if you write sine without a variable, it's a sin. Okay, we're not a church. So, sine theta, cosine theta, you gotta have a variable. If you don't like thetas, use x's, okay? So, in the first one there, it says write tangent in terms of sine only. Okay, well, let's think about what we know. Our first identity, our reciprocal identities, tangent only goes to cotangent. So we probably don't want to use one of those. But we also know from our ratio identities that tangent is sine over cosine. All right, well, it said we could only use sine. So, do we have another way that we could write cosine? We sure do from one of our Pythagorean identities. Okay? So, if you look down here at the bottom, hey, look, I got a cosine, and he is 1 plus or minus the square root of 1 minus sine squared. All right, well, I'll plug that in. Now, this one's kind of gross, and we're going to actually leave that in the denominator for right now. We're not actually going to rationalize that one. So he just has, I can only use sine, and that's what I've done. All right, so look at number 2. Write secant theta times tangent of theta in terms of sines and cosines. All right, well, secant. What do we know about secant? Secant is 1 over cosine. All right, so secant of theta is 1 over cosine of theta. And tangent, we just did it up here, is sine over cosine. This one said we could use sine and cosine, so we're going to use both. And now let's simplify that. Multiplying fractions straight across, I get sine theta over cosine squared theta. And I can be done because it said I could use both sine and cosine. All right, number 3. Says I'm going to add 1 over sine theta plus 1 over cosine theta. Well, in order to add fractions, they need a common denominator. If it's in one of them, it's got to be in the common denominator. So my common denominator is sine theta cosine theta. Okay, what's new over here? Well, I gave this guy a cosine. So if I gave it to the denominator, keeping equality, I got to give it to the numerator. What's new over here? Sine. So, gave it to the denominator, got to give it to the numerator. So, I get cosine theta plus sine theta all over sine theta times cosine theta. Number 4, we're multiplying them, so we're just going to FOIL. Sine times sine is sine squared. Sine times negative 5 is minus 5 times the sine of theta. 2 plus 2 times the sine of theta. minus 10. Combining like terms, I get sine squared theta minus 3 sine of theta minus 10. Number 5 is where we get into some stuff that's a little bit trickier. So it says prove the statement is true by transforming the left side into the right side. We're not going to cross the right side at all. I'm going to rearrange and use my identities to rewrite cosine theta times tangent of theta, and I'm going to get sine of theta when I'm all done. Okay, so this is my do not cross line. I'm going to turn the left side into sine. Okay, we're not going to do a whole lot of stringing across our paper sideways. We're going to work vertically when we do this. Okay? Alright, so cosine. My hints at the top were to go to sine and cosine first. So if it's a cosine, I'm going to leave it. Tangent. This is the one where we don't really want to go to cotangent. We want to use our reciprocal or our ratio identities. So I'm going to say leave cosine. And I'm going to say tangent is sine theta over cosine theta. Well, look what happens there. I have a cosine theta in the numerator, a cosine theta in the denominator, and when I simplify that, I get sine of theta equals sine of theta. You need this last step. I must see sine of theta equals sine of theta. Okay? You're working all in the left-hand side here. You're working vertically, and you must write this last step down here at the bottom. Okay? So, number 6. All right, number 6. Again, the same thing. We're going to prove the statement is true by transforming the left side into the right side. We don't change the right side at all. We're just going to work with the left-hand side. Okay, so I have sine plus cosine all squared. Well, let's go ahead and write that out. So I have and then let's go ahead and just FOIL that guy out. So sine times sine is sine squared. Sine times cosine gives me a sine theta, cosine theta. Cosine times sine, I'm going to write it the same way. And I know I said don't cross that line, but I ran out of room. So plus cosine times cosine gives me cosine squared theta. Okay, now pause for a second and look at what we're trying to get to. I need 1 plus 2 sine cosine. Well, I've got 1 sine cosine there, and I got another sine cosine there. So I have 2 sine cosines. Okay, so let's rearrange it. I have sine squared theta plus cosine squared theta plus 2 sine theta cosine theta. Okay, so I have that part. Now I have sine squared theta plus cosine squared theta, and I need that to equal 1. Well, guess what? We have a Pythagorean identity that does just that for us. Cosine squared theta plus sine squared theta equals 1. See why you need to have them memorized? Because you're going to be using them a ton. If you don't have them memorized, you're probably stuck right here. So I do get 1 plus 2. Again, those two together is my Pythagorean identity. 1 plus 2 sine theta cosine theta. Show me this last step equals 1 plus 2 sine theta cosine theta. Again, at the top, I didn't read the first part, but it says the ability to prove identities in trig is not always easy. It requires a lot of practice, repetition, and patience. And that's the true with math. You just got to keep practicing them. Okay, and if you have those identities memorized, it makes it go a lot faster and a lot easier. Okay, last one. Number 7. Says simplify the square root of x squared plus 9 by substituting 3 tangent of theta for x. Alright, now some of you are going to say, okay, I'll just take the square root of that and it'll be x plus 3. No, you can't do that. Okay, remember that doesn't work. There's an operation in here and we have to do that first before we can take the square root. That's a grouping symbol. We got to do everything under there. Okay, so I'm going to substitute 3 tangent of theta in for x. Okay, I have the square root. of 3 tangent theta squared plus 9. Okie dokie. Well, let's just square that. 9 tangent squared theta plus 9. Again, I still can't take the square root, but if you notice, what do they have in common? A 9. I'm going to factor it out. 9 times tangent squared theta plus 1. Okay. Now, this is one you probably don't have memorized, but you do have your identity chart here with you. And what do you notice about tangent squared theta plus 1? It's secant squared. Okay, I'm going to replace that with secant squared. So I have the square root of 9 secant squared theta. Okay, did I get rid of the plus sign? Yes, I've gotten rid of the plus sign. So now I can take the square root, and when I take the square root, I get plus or minus 3 secant of theta. So we started out with 3 tangent squared plus 9, taking the square root, and I ended up with plus or minus 3 secant of theta. Okay? Again, I'm going to say it again. You got to memorize those identities. Okay? Anything that I put a box in on the last set of notes, your reciprocal identities, your ratio identities, your Pythagorean identities, you have to know them, and it'll make it ever so much easier.